Alright, we're live. Hello all, hello world. Yeah, I skipped yesterday because I had a bit of a nightmare final to worry about, but that's all done and resolved now. I ended up sleeping like 1.5 hours. I took the final. It seemed to go well, so yeah, surely that's good news. Yeah. After that, I took like a giant nap, which is kind of why stream is pushed back a little, but yeah, we're here. I don't think I'm gonna write any code because I'm gonna be doing a lot of reading this time. But yeah, it's gonna be a good time. Yeah. So last time we finished up tree tiling, which I think wraps up or I'm dumb here. Regalloc. Did I get the description wrong actually? Let me check. Yeah. Last time we finished instruction selection. This time I want to at least start planning out like regalloc, which is register allocation. Let me check the description of the video, or the stream, I guess. Which is register. What's good, Niraj? Good to see you. Damn it, I got it wrong. Okay, edit video. 1 second. Regalloc. Okay. Okay, cool. So that should be fixed now. Yeah, that's gonna be today's plan. So we have this giant, I guess, graphic that I drew last stream, which kind of visualizes like where we are at this in terms of like our next steps. We just finished this little green thing here, which is instruction selection. So we've taken the MIR and we've mapped it down to LIR in some way. So now what we have, if we look at the output that we have, I guess, from the tests. So if we go to like expected, yeah, so we have like a bunch of, we have a bit of a mess here. There's a couple of things that we need to worry about. The first one is that we have this whole pile of like virtual register, or virtual physical registers, I'm calling them. There are potentially things we need for the calling convention, but we don't really know which registers we need yet, so we can't particularly, you can't really do anything with them yet. So that's like one concern, at least. So I'd like to at least figure out which registers we need, which is one of the reasons that I'm doing register allocation. The second thing is we have these fee variables, which are kind of like, I guess, copy or match hints, I guess. This isn't like real assembly, so I need a way to turn that into, I guess, like real registers at least, or use that to help mapping registers. And then the final thing is we have like register 1 here, which, well, obviously isn't a real register. So we would like to put that into a real register in some capacity. So yeah, those are kind of the 3 things I want to get done with register allocation pretty much. And this should, I think after this, we should just have like fully functional assembly, I think. Or yeah, and then we can just like, we can turn that into, we should be able to just turn that into code that we can output with like a couple changes here and there. Something else I'm thinking about is maybe I could like clean up the calling convention stuff a little bit even. I don't really know how I could do that at least. Yeah, I think I do just have to vomit out all the virtual slush here, which is kind of inevitable, but it is what it is. Okay, so I believe last time Harold also introduced me to the greedy register allocator that LLVM has. So I want to read up a little bit more on that right now. I think that's a pretty solid use of my time. Description changed? Yeah. Because I was incorrect. It's not instruction selection, it's regalloc. Okay. So LVM greedy register allocator. Oh, this is this kind of just like the same talk? Oh no, this is an explanation. So this is like, I guess, how it works. So yeah, I guess we'll have a fun time here. I don't understand what's happening here. Oh, I see. Okay. Sure, okay. So we skip a bunch of steps there. Yeah, okay. Yeah, this... Maybe I should have just inserted it at a different time, actually. That might have been smart, huh? Oh well. Yeah, okay. Well, whatever. Okay. I guess... I don't know. Is there a downside to doing this sooner? I feel like not, right? Like, maybe it makes the calling convention look ugly, but like... It should still be correct code, in theory at least. The code that we generate. Okay, live interval analysis. Yeah, we need to... That might be a good thing to start with, actually. Just like liveness analysis. Yeah, this makes a mess. I'm not happy with this. Or not happy with having to do this, at least. Okay. Spill weight. Okay. I guess that makes sense. I don't know. I don't feel like I need to be particularly great with the way I do regalloc, because I don't think this is like a very large focus of what I want to do. I could just do the linear scan algorithm, to be honest. Okay, so that's every interval. Okay, I guess that kind of makes sense. Okay, and then everything else is... Oh boy. So what are these intervals? Where do these come from? Oh, I see. Okay, that makes sense. Okay, so we have two registers. We throw them in wherever possible. So then we have to boot something here. So you just kick whatever is the least weight, it looks like. And we throw X back into the queue. Interesting. Okay, and then if we can't evict, we just... Okay, we mark it to be split, and then we worry about that later. Huh, okay. This actually makes a lot of sense. Okay, then we can do that. Okay, how does splitting work? Okay, so we add a copy. Huh, okay, that makes sense. I see, okay. So when we compare spill widths. Okay, so then we just boot Y again, I guess. That makes sense. So interference with both, so we need to. Can we evict? No, so we mark this to be spilled. Right? Or split, I guess. Yeah, split. Split first, then spill if we have no choice, I think. Okay. How does this get split? Oh, we're just assuming no here, I guess. Okay, so now we spill. How do we spill this? Spill after death. Oh, I see. Okay. That makes sense. Okay, I see. And then we just keep doing the thing, pretty much. That makes sense. Okay. Why did it create these? Is this the old allocator? Oh, I see. Oh, that's that's so stupid, actually. Oh, that's so dumb. Like, it's smart, but also, like, it's dumb, I guess. Okay. I guess that makes sense. This is a hard problem, so I don't expect to really do anything interesting, but does not know what happens to X inside the basic block. I don't understand this, to be honest. I guess that roughly makes sense at a glance. What's good, Armand? Good to see you. Yeah, I am reading about LLVM's greedy register allocator. That might be something I try to implement. That might be something I don't try to implement. I'll figure it out after after looking at this a little bit closer. It doesn't seem that bad though. I think I'm gonna need to like do liveness analysis regardless. That'll be fun. That'll be very fun. That's so annoying. Oh, this is stupid. This is a really funny graph to see because it's just straight diagonal. I guess that makes a lot of sense. But like, holy hell. Again, we just check for this. It looks like multiple reloads from the same location. Fix. Sure, okay. Okay, cool. So I don't think it's that theoretically difficult to implement the greedy allocator. Alright, and it shouldn't be that bad. Like, it's still gonna be fucking awful, but I imagine it sucks less. But there's so much infrastructure we need to build. Okay. How do we... Okay, so what do we even do with this? I guess that past read-through I just did was from the perspective of figuring out what's even happening. So now I'm gonna go through it again, but like with the lens of like trying to implement it, I guess. Okay. Oh, what's good? I'm fine. Kagama, I don't know how to pronounce your name. Apologies. Okay. So this is like kind of the pile we're looking at. So I guess we could split screen this, I think. Let's actually put this in. Let's make a new thing here. Let's call it like regalloc. This will be like my stream notes pile. What the? Okay, cool. So we can split it like this. Yeah, let's give this a try. Okay, so minus analysis. That one I think I'll have to do regardless. So that's kind of just the cost that we're going to deal with. Yeah, I'm gonna need to refresh how to do that, but that seems a little bit annoying. I will have to do that anyway, so like it's fine, but still. Yeah, okay. So this is a def, this is a use, and this is a use. So we're splitting it like there, I guess. So we connect those. Yeah, okay, that makes sense at least. And we can represent these as like ranges, I guess. Also making a language that transpiles to JS, and you're making a compiler just studying. Ooh, that seems a little bit unwieldy. Yeah, good luck on that one. I am building a compiler from C to x86-64. It should, yeah, it's like this giant code base that lives here at least. It should be public on my GitHub if you want to take a look, but I don't think I'll be going too into this at least today. Maybe I'll like template out like one file or something, but I won't be doing like a whole lot of work per se. Okay, so we have liveness analysis. So this is like regalloc proper. So for every interval, we want to do like spill weight calculation. Also, that reminds me, I should probably look at what the books are saying for register allocation as well. That might be a good lead as well. I think those will be easier to implement at least. But this is like the most interesting to me. Okay. Live internal analysis. I don't think I could really do a lot with this, to be honest. How would I even do this? I don't have the tooling or infrastructure, I think. Yeah, okay. I think I'll just be lazy with this. We can just like make a heuristic. This will just like really suck for loops though if I do it like that. Let's ask ChatGPT. What's a good heuristic for spill weight in register out? I guess that makes sense. Yeah, this is annoying. Oh, I have to rebuild the CFG? Oh, hell no. Oh, that's annoying. Outputting assembly seems scary. I cheat the native target by outputting JS. That's fair, yeah. Like I remember like while I was trying to figure out what I was doing for research, like my mentor was like telling me how like it's just not worth it to link even just to use LLVM's tooling because well it's a mess. It's like literally easier to just output C and then just use Clang and call it a day. Which I think is crazy to think about. And like Loki, I don't think he's wrong. Like I tried oh my god, this is gonna sound so stupid. I tried running like an LLVM pass, or like running a custom LLVM pass that I wrote. It was very easy to like get it to run for the Rust compiler, but Clang just was not taking it for some reason. So I'll be chatting with my mentor tomorrow, but yeah, it's like LLVM is just very poorly documented and it makes such a mess. And I guess the mess that I'll create by rebuilding it from scratch is it's gonna be a little bit worse. Okay. Ah, okay. That's annoying. Okay. So how do I even do this? This is very annoying. Like, I guess this makes sense. I should do this sooner, but like, damn. Okay. This seems a little bit insurmountable. I might This might be a little bit awkward. Yeah, okay. I'm gonna write a note that this might be a little bit difficult for now. Yeah, this might be a fun thing for like a stream a year down the line, but for now I just want to generate assembly. I don't particularly care about how efficient this is. Like, I'd want it to be efficient, but it's not the end of the world if it's like a little bit slow, I guess. Expect a lot of tears when working with LLVM. Yeah, I have to... Oh boy, I'm gonna have to do that for a living eventually, huh? I mean, I guess that is the point of this series, but like, damn, that's that's gonna be fun to work with the glue for, I guess. Okay, priority queue construction. Okay, so global and greater span are higher priority, I guess. We'll just do PQ construction. All tables have lower priority. Oh, actually, I could do this way sooner. Actually, that could be very helpful. That seems very smart. I should definitely do it like this. Yeah. Interesting. Yeah, okay, and then global variables, span. Yeah, this also seems very difficult. Okay. Yeah, so then that's done in theory. Okay, register assignment. This is just like one like work list, I think, pretty much. Okay, so if assignable, assign. Okay, so that's like the easy part. So those are easy. Okay. So if it interferes, then if, I guess, lowest spill weight. I guess move lowest spill weight back to PQ, and then assign. If all are greater spill weight, then what do we do here in this instance? Okay, so this one is the lowest spill weight. So then mark to be split. And requeue. Re-in-queue, I guess? I don't know. Is that English? I hope that's English. Okay, we can do that. And then, yeah, so that gets like lowest priority. Okay, and then we keep doing that. Okay, so I'm splitting. How do we know if a split is beneficial, I guess? If marked, mark, what is this again? Mark to split. So then find best split, and then add copies between intervals. Spill weights, and then we just re-queue them, I guess. Re-in queue. Yeah, I should break this up into another line. We can do it like that, I guess. Yeah, we can do it like that. In theory. Okay. Okay, so then we do more shuffling again. If no good split, then we want to spill around uses, and we can learn that as we go. At least this seems really difficult though. Okay. That's kind of like the pseudocode at least. Let me save these slides somewhere, because this will be very useful to keep around at least. Okay, let me just, yeah, I'll throw that there. Okay, so this might be a little bit out of my range, because there's a lot of analyses that I need to write, which is specifically these ones at least. That seems really annoying, and I would like to avoid that as much as possible. I've just accepted that I will need to do liveness analysis regardless. So that one is like guaranteed doomed at least. So I'll figure that one out. Yeah, let's see what the big textbooks I've been reading have for this. Let's look at the Muchnook book. Hopefully there's something good in here for this. Huzzah, okay. Okay, this page is a little dark to read. It's in my preferences, right? Is that the help? That's help, yeah. Okay, menu, preferences. Is this a little bit brighter? Okay, perfect. regalloc and assignment, most important. Low level intermediate code or on assembly language. We're doing this on pretty much assembly language. Quick and reasonably effective local method. Okay, that makes sense. Yeah, this might... Oh, wait. Graph coloring. Yeah, I think this might be the... This might just be what we do, to be honest. I think that will be the easiest one for me, because it has like the least external dependencies. This bin packing thing is interesting to me. Resource allocation of graph coloring, yeah. Two quantities must be in ranges, Interferences, yeah, something about interference graph. This is like the method that I'm very much more familiar with. I can't say I am familiar with it, but yeah, it'll have a little bit more familiarity to me at least. NP complete, yeah. So this is gonna be a little bit tough. Yeah, and then like if we physically can't fit every register we want into, or if we can't fit every register in at the same time because we don't have enough registers, we will just make stack variables pretty much. But that's a little bit annoying, so we'd like to avoid that if possible, pretty much. Okay. Turn switch of the values. That might profitably be okay. Yeah, that makes sense. Okay. Yeah. Yeah, register operations are fast. Memory operations are slow. We want to avoid memory. That's like pretty basic systems theory, at least, I guess. Okay, graph coloring. Parity-based graph coloring. Oh, interesting. That's cool. This would be the dream, but I would need to rewrite a lot of stuff, so I'm not gonna do that. Okay. Register assignment. Trade her risk. Yeah, I think that's like fine for us, right? Low key. Oh, I lied. Yeah, okay, cool. Wonderful, great. Great, cool, wonderful. Wonderful, great. Great, wonderful, cool. After generating low-level remission code. Okay. Preceded by instruction selection and software pipelining. More scheduling, yeah. The nice thing is, like, the way I'm writing this, you can kind of just stick this wherever. So, yeah, it'll be fine. Global optimization on low-level code. Last optimizations, yeah. So we can just throw this into the, we can just throw this in whenever, pretty much, depending on like what opt level we care about. Suppose all addressing calculations. Yeah, I'm quite tired already. I say already like it's really early or something. This is like a normal time for someone to become tired. Okay, so expose all calculations. Yeah. We already do that, I think, so we're fine on that end. So on intermediate code, let's see, a few registers to be reserved in code generator. We use as temporaries. I guess that, yeah, that makes a lot of sense. Distinct drawback of the priority-based graph coloring approach. Oh, interesting. That's, huh, okay. What kinds of objects should be taken as candidates for allocation to registers? This book is quite old, actually, so I hopefully this is not like too out of date, but yeah. Actually, why doesn't LLVM use graph coloring? Or why doesn't LLVM use graph coloring? Ah, full blind. There we go. That's pretty funny. Wow, this is all so old. 2007, like, damn. Can I like unselect that? No? Okay. Okay. Okay, I didn't get full blinded there. That's good. Yeah, this is correct. This is correct. Yeah, that's still true. How to grind like this? Start streaming, get the whole internet to hold you accountable. I'm joking. I think the big thing is just like, or the reason why streaming helps me do this is because it forces me to set aside at least a little bit of time every day to just like work on this. And I know it's like really awkward saying that just coming out of a day where I like literally canceled stream because I had a final to study for, but like on most days I think if I don't have a very strong reason to not stream, I will be streaming. And I think you could do the same even if you don't want to stream, at least just with like setting aside time to work on like a personal project or like setting aside time to study whatever. Yeah, like, yeah, I think for me at least, it's very hard to not justify streaming, especially when I just like waste so much time just in general outside of stream hours. So yeah. Yeah, this, I'm so lost reading through this. Not because of like I'm so lost because I can't figure out what they're saying. Or I can't follow what they're writing at least. Why is my voice like dying? It always pop up on my feed all the time. It's the first time I got a live stream recommended. Ooh. Well, welcome to the streams, I guess. By compiler role, I mean a job, yeah. So like, I guess specifically a full-time role where I can like work on compilers. I do have a compiler-related internship this upcoming summer, but I low-key enjoy streaming enough to the point where I will gladly just like push that to the side because like it's not full-time, and I will just continue to use the title for clickbait low-key. What is the PBQP allocator? W compilers? Yep. I quite enjoy compilers. I think that's pretty obvious at this point, but yeah. Okay, what is this? Okay, that makes sense. So cost per register? Or... I don't understand this. I guess the duty table is like an interference graph, sort of. Interesting. Oh, yuck. That's gross. Made one for my class my junior year? Ooh. You see, when I took it, it was in Python. Ah. Well, I mean, that's still pretty cool, though. I feel like it's always, like, really funny to work with, like, Python on, like, systems sort of projects, because then you're really pushing Python to its limits of, like, usability. And that's just, like, a really funny concept to me for some reason. I don't know. Holy hell, my voice is dying. Okay. I still don't really understand what... Okay, what is PBQP? I don't understand this. Oh, I guess that makes sense. NP hard. Deep RO. Ooh, okay. Second year CS right now, and just a bit confused what to do right now, how much to leverage AI, and what projects to make. I think a lot of, so I guess I am a fourth year. I'm finishing my undergrad degree and starting my master's at the same time. I think second year is probably the best time to just like explore a lot and to figure out what specifically you want to work on. So like maybe take some time to like play around with like PyTorch. Like the web dev stuff that like you've like mentioned is like pretty solid. I think that's like a good start. But also like make sure to, I think like that's the most resumeable at least. But make sure to like also take some time just like looking at like other fields of computer science and just like really figure out what you want to work on, unless you're like already dead set on like doing web dev stuff. So like maybe take some time like playing around with PyTorch, and like using PyTorch to like even just like make a basic like classifier, or make a game or something, using Unity or like whatever game engine, or like I guess even just make a compiler. I don't know, like there are so many different areas of computer science that that are like very easy to miss at least, if you just like focus in on one thing too early. So I think that is the biggest thing I would suggest. In terms of leveraging AI, I think it depends on what you're trying to do. If you're trying to just like make something, I think it's fine to use AI. Like you very much will be told to use it at most tech jobs that you go to, I think. But if you're making a project just for like pedagogical reasons, like literally just to learn the thing, I think it is a little troll to use AI. So like use it at your own discretion. The bright line I set for myself is like, if I'm doing this to learn, I will. If I'm doing it to learn, I will not use AI to write code for me. But I will use it to like help explain things or like debug code maybe. And like if it's like some sort of like helper script, like a test runner or something, I will very gladly outsource that to the LLM, for instance. Senior doing internship right now. Ooh. Fall internships are really cool actually. I feel like I should have looked for one in the past. But timing wise it seems a little troll for me to look for that. I've done a full-time role, I do web dev. That seems like pretty standard. Yeah, hopefully you get the return offer. I imagine you will if you're just like putting in the hours and just like not messing up pretty much. Okay, what is PBQP? First two. Yeah, this is like an example of where I would use ChatGPT. I'm not using it to write code, but I'm using it to figure out what the hell is going on. Okay. Oh, that would be funny to write actually. That could be interesting. Okay. A2 and B1, 6. Sure, okay, that makes sense. Interaction costs. I don't get this. Oh, I see. Okay. That makes sense, I guess. Oh, okay. So this seems like a really annoying problem to solve. Which makes sense, I guess. Okay. Not every variable can use every register. Yeah, okay. That makes sense. Sure. Okay. That makes enough sense, I guess. Personal assessment from McKinsey. Oh, that's pretty funny. Loki, I wonder how consulting firms will work out for tech jobs at least. Because like on one hand, like they're absolutely gonna still be around. On the other hand, like they're going to spend as much effort as possible to replace its workers with generative AI. It's very interesting to think about. Anyway, let's take a step back from this PBQP pile. Let's just go back to the book here. Okay. First, is hierarchical, weights inner loops more heavily. Yeah, this is like kind of what we look at. That makes a lot of sense. This is like the greedy thing. Something about liveness. 8 depth is. That's pretty smart, actually. How you guys get your internships in Canada, so it might be a bit different, but you're doing it through connections or cold applying. Yeah, honestly, it's not an easy market. My first one I got through cold applying. The one this past summer, at least. And I think I applied to roughly like somewhere between 100 to 200 companies. And it was like, yeah, it was just like, it's kind of a volume game, I think, if you don't really have anything to leverage. But if you do have something to leverage, then you can like be more selective with it, at least. Like I was a lot more selective this past recruiting cycle because I wanted to do compiler stuff, and I had like some compiler stuff on my resume, so I figured I could just like I don't know, I guess like it just made sense for me at least to only really target compiler roles at this point. Like I'm at a point where I can probably justify that. Compiler roles and like maybe somewhat adjacent ones. But the internship I got for this upcoming summer is that one I got through the career fair. Like I chatted with the guy at the career fair. It turns out he did not study compilers a lot, so he kind of like picked my brain for like 10 minutes. So I think just like having really good conversations with connections is like definitely very plus EV. I think it's a combination of volume and then like the ones you do actually like really care about, making sure you put the quality in. This is annoying. Bin packing. That save. Okay, sure. This feels like I'm reading like an econ textbook or something. Yeah, hackathons are another great place actually. Cause like it's just like it is kind of just like free networking slop, I guess. Even if you go to a hackathon and just like don't do the project and just like spend the whole time networking, I think that's like unironically not a bad use of time. But also like it depends on like what you want to be working in at least, so your mileage may vary at least. Okay. Yeah, okay, sure. Bin packing. Lifetime temporaries and then divides them into groups. Oh, that's interesting. So then we just go like most specific to like, or most specific to like least specific, I'm guessing, right? I guess the memory location ones, we kind of just assume we have memory, so I imagine we're not concerned about that one too much. John Cock, nice. Okay, graph culling. This is the one we care about, and this one takes up a lot of stuff. This takes up a lot of pages. Oh, why is that page full blind? Yep, still scrolling. 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 There's a lot of diagrams, which fair enough, but yeah. I think this gives pretty good visuals, I think, so yeah. That should be good. And okay, that's all the pages for that. So up to 524. This starts on page 485. So we've got like 50 pages of reading roughly. I think that's what I'm gonna end up spending the rest of today doing. Learning Go right now because I like backend more and Go is a pretty fun language. Yeah, I think I haven't written any Go, but from the friends I've talked to that have written it, it seems like a very fun language to write. it seems like a good language as well in terms of like employability as well. Oh, what's good, Miss? I get to see ya. Yeah, I am. I might be Unk. Okay. Sure. Okay, 5 steps. So first, allocate objects like being assigned to registers, to distinct symbolic registers, using as many as needed. Then we determine what objects should be candidates for allocation to registers. Then we construct an interference graph. This is a little bit annoying. Nodes represent allocatable objects in the target machine's real registers, and whose arcs represent interferences. So we make a graph. We make a graph of all of the registers, both the virtual ones that exist and the physical ones that we can map to. If there is an edge between two nodes, that means they cannot be the same, pretty much. And that lets us figure out, I guess, a bunch of important stuff. Nice talking to you, very insightful. Done eating, so I'm gonna work on my assignment. Ooh, fun stuff. Wish you good luck, and hopefully I see more of your live streams in my feed. Thank you. Thanks for stopping by. Good luck on your homework, and have a wonderful rest of your day. Okay, yeah. So if there is an edge, they cannot be put on the same object. Okay. Some color the interference graphs nodes with R colors. R being the number of available registers. So if we have 16 registers, we do like 16 coloring, I guess. Yeah. So allocate each object. Yeah. That one should be like relatively simple. These two are like the really annoying ones, at least. What's regalloc? It's short for register allocation. So we have a bunch of variables. We only have so many hardware registers. We want to put all of those onto as many of the registers as possible. And then for the remaining ones that we can't put on, we want to make sure that like we're choosing the best places to, I guess, turn them in, read and write from stack memory, I guess. What's good, AK? Okay. Example of the basic approach. Okay, Y and W are dead at the end of this. Okay. Wait, this is literally just... we might have SSA here. It's pretty funny. Okay. Y and W dead. And then we have 3 registers available. So we have R1, R2, and R3. And then we're making like, this is the original code on the left here. We have virtual registers S1 through S6. I guess symbolic is the word they use here. Yeah, so this is what the interference graph looks like, it seems. So R1, R2, R3 all have edges to each other, which, well, makes sense. Yeah, because yeah. If something is R1, we can't put something that is in R1 in another register, I guess. Do you remember the fast fetch incident? Yeah, it should be the local. It should be local IP. I'm not very concerned about it. Yeah, because I ran it on my WSL, so yeah. Okay. registers are available. Z must not occupy R1. Yeah. Wait, why can't we do that? Okay, wait. So S1 interferes with S2 because S2 is defined in line 2 between the definition of S1 in line 1 and its uses in line 3, 4, and 5. So S1 is used here, S1 is used here, S1 is used here, S1 is defined here. We can't overwrite whatever S1 lives in with S2. That makes sense. So we draw an edge between them. Yeah, that makes sense. S4 interferes with R1 because Z is restricted to not being in R1. Did we physically restrict that somewhere? Yes, we say that at least. So we're assigning to Z here. This becomes S4, so S4 must not be with R1, so we draw an edge between them. As a compiler, we're going to work on x86, only x86-64. We're going to make a cross-platform. Currently, my plans are x86-64, but yeah, you're correct. I need to basically write a fresh backend per platform, so that's a lot of work. For now, I'm just going to target x86-64 because I mostly only care about the middle end. The backend exists insofar as we need to generate code, and I want it to be somewhat performant. So yeah. Okay. Yeah, so we can color this with 3 colors. If you've done any semblance of a discrete math course, you'll remember graph coloring, and well, that's what we're doing here. So yeah. And then we color them, and then life is good. And then we look at the physical registers. This one matches with some colors, we make them the same register, or we put them all in that one. This one is some color, we put all of the matching color ones into that one, so on and so forth. Okay. Diffuse chains that intersect to form webs. This is so annoying. It's quite difficult. Where is this figure? 16.4. Okay. Oh wait, we just have diffuse chains. I think we could just use those instead of... Wait. If we just have diffuse chains... No, because we don't map 1-to-1. We need to do liveness. Damn it. Okay, well that's fine, I guess. I'll just do that. Sure. Webs, objects for which registers are allocated. SLing as a project on your resume, is it good or bad? I don't know. I think it's probably fine. It's just why, I guess. If you say you can write it, then I truly think no company cares. But if you're writing writing an interpreter or a compiler for it, then sure, maybe. But I think also that kind of limits a lot of... It sets a ceiling on how much complexity you can encode into it, I think, right? And if you're gonna make it complex, you may as well just use a real language at that point. Compiler for it? Yeah. I think my point still stands. A liar I mentioned. Lol. build the adjacency matrix. This is just the interference graph. Coalesce wedges. Oh, interesting. Okay. And then we continue step 1, which was what again? Make webs. Okay. I guess we kind of do the opposite of this, I guess, with Fuse. We like assume we can coalesce, and then if we can't, then we just make a copy. Build adjacency lists. So we construct the adjacency list representation of the interference graph. Oh, I guess that makes sense, yeah, okay. Spill costs. Yeah, that makes sense. Sure. Prune graph. Sure. Okay, that's annoying. Okay. So while true, we make webs, we build a adjacency matrix, we coalesce, if possible. We keep going until we can't coalesce anything. And we build the adjacency list, we compute spill costs of each register. So this stuff up here is like optimization, I think, and setup. So we do spill costs, prune the graph, and then we try to assign. If it works, then we assign it, otherwise we generate spill code, and then we try again, pretty much. And by generating spill code, I guess we're just like, or maybe I could try to generate split. I don't know. I'm kind of lazy. That seems difficult. Let's just spill a register if it fails. Okay. Some types of register contents that may be handled differently in ways that are less expensive. Yeah, okay. Prune graph. Oh, that makes sense. Assign wedges, use the adjacency list, try to send colors. Sure. Gen spill code. Okay, yeah, so that makes a lot of sense. Maybe I should save their preamble stuff for after this, actually, in case I need to like spill things anyway. I'm gonna need to allocate more space, which it'll make a mess. So yeah, that might be important. Webs, huzzah. Interesting. I think my brain's a little fried, honestly. I might just call the stream early and chill, low-key. Yeah. Finals week is rough. Yeah, I think that's like a pretty good overview of graph coloring. I think this is going to be what I work with just because it has the least external dependencies. So I think that will be the algorithm I use. Yeah, let's just like put a note here. Coloring, use this one. Yeah. Finish my finals, damn lucky. I have my OS final on Wednesday, and then I have like a game dev final on Thursday, and then I'm done. But like, fuck, I'm quite tired. Alright, I'm gonna flip a coin. If it's heads, I continue streaming. Oh. Okay, well, okay. Guess I'm still streaming. Okay, cool. God damn it. Okay. Okay, I'm gonna flip it again in 5 minutes. If it lands heads again, I will continue streaming again. The instant it flips tails, I will. The instant it flips tails, I will call the stream. Okay. Okay. Sign wedge makes sense. This is like pretty trivial, I think. Stats problem with R? Yeah. It's all just theory at this point. This page is just full blind, I guess. Unlucky. Oh, that helps a little. What even is a web? Is it literally just diffuse chains? Huh. Okay. Summer project, built my own programming language engine. Ooh. That seems pretty fun. Yeah, welcome to the stream, I guess. I'm learning about register allocation right now, because I need to generate assembly. And generating assembly is really, really annoying and really difficult. Does my boba even have boba in anymore, or is it just ice? Oh, there's two bobas, I think. I'll fish it out later. Yeah, okay. Webs. Names, now generally called webs. Okay, so this is like... I guess I could just think of this as like live ranges. With your coin tosses, yeah. At this rate, the ice will melt fast enough so that I will be able to pick it out easily, surely. Okay, yeah. So this is like live ranges, pretty much, is what I'm getting. Abstracted flow graph. Yeah, I will just do liveness analysis for that, I think, and call it a day. It seems like I will need to do liveness analysis regardless. Which, well, sure, fair enough, but like, damn. I don't want to write that shit again. That shit's hard. Yeah, okay. Variable names suck. That makes sense. Yeah. Okay. Man, this is gonna be annoying. This is gonna be really annoying. Okay. Real as fuck, thank you. I hope I'm real. It'd very much suck if I wasn't real, at least. Okay. I don't think I care a lot about make webs here. This is just like generating live ranges, pretty much. Yeah, I don't care about that algorithm. Interference graph. This is where I start caring again. Okay. So there's one node in the graph for each machine register, and then we have one for each, I guess, live range, maybe? That seems... I guess live range makes sense here. We might just have to split variables more, and it'll be really funny, but yeah. we'll see what happens with that. I have ideas on how to do this. AI live streamers are gonna be crazy. Yeah, that's. I'm not looking forward to that one. Oh, I'm gonna need to rename the variables again for live ranges if I'm like splitting them. Okay. Okay. Yeah. Okay. So we set each live range as a node, and then each machine register also gets a node pretty much. Calling conventions, stack structure, okay, yeah, sure. Target machine has 2 or more sets of registers that could different problems. Yeah, okay. We kind of have to do it all in one place, it seems like. But like, that's like fine anyway. That doesn't really matter. 2 nodes have an arc between them if they are ever simultaneously live. There's on many more arcs in the graph than are needed. Sufficient to include an arc between nodes if one of them is live at a definition point of the other. Okay, that makes sense. Additional arcs. Significantly increase the number of colors required. Okay, we could do like a line sweep for this, I think. It's like we just over all of like at each point in the instruction at each point in the program, we check which variables are alive, and then if there's a new variable that is alive, we draw an edge from that to everything else that exists at the same time, I guess. I think that should be reasonable enough. Yeah, I will. Let me just copy this over. Oh, that actually pasted surprisingly well for a PDF. Okay. Yeah, okay, that makes sense. Neoven drawer, yeah. Funnily enough, if you watched my previous streams, you will notice I was like doing notes in like Notepad for some reason. And like someone asked in the comments like, why are you using Notepad? And I was like, yeah, that's a good question, I don't know. Yeah, I'm just very used to using Notepad, but Neovim makes me happy. I'll use Neovim. How did you get into compilers? I took a class and I thought it was fun, so then I did research. And I guess it's just gone from there, I guess. For stream? Oh, bet. Well, I guess welcome to the channel. Thanks for thanks for stopping by on a stream. Write everything in Neovim except notes. I mean, I use like Notion for, well, okay, that's a lie. I kind of don't really take notes, which is a very bad habit, but I don't know. I've been enjoying, I feel like Neovim for notes isn't really that bad, to be honest. Maybe if I use like Obsidian or something, it would be better, but so it goes. What's good, Ross? Good to see you. Okay. 21 colors and versus 11. Oh, that's that's annoying. What is the name of this book? This is Advanced Compiler Design and Implementation by Muchnick. It's like a 1997 book, but it's very, very comprehensive. Yeah. Emacs org mode. Ooh. Emacs is quite unlucky, but I guess there are worse fates to succumb to. It's not my chair metal support part in half by wing. That's tough. Hopefully you're doing all right, Fortnite gamer. Okay, how do we represent the interference graph? Space efficiency, access time. Construct, determine whether two nodes are adjacent. This is just going to be really slow, I fear, unfortunately. First use VS at work. Oh, that's tough. Crafting interpreters, yeah, crafting interpreters is like my go-to beginner recommendation, actually. I think it's great for like just getting your feet wet and like just getting used to like PLT, I guess. If you want to like actually work on, or if you want to like find a book for like compiler stuff, I have been told that Writing a C Compiler by Nora Sandler is really good. I guess if you want to like check it out, if not, then like fair enough. Traditional representation. What does this mean? Writing a C compiler by Nora Sandler. This book. I have heard very, very good things about this book. POV progress is actually better now that the original dev quit. Oh, that's crazy work. Yeah, that's good to hear. I remember you mentioning that the mod is just like a mess. Yeah, of course. Access time. Yeah, okay, I read that already. Yeah, okay, that makes sense. T and F. I could just use like a bitmap, right? Oh, that's really annoying. Color. We're going to use numbers for color. Okay, displacement, that forms the address. If spilled, that makes sense. Spill cost. Number of ints. Number of interferences. Okay. Okay, so it's just a bunch of metadata, which I guess fair enough. Thank you, Russ, for a donation. Yeah, I still don't know what YouTube calls. I don't know what YouTube calls donations. Super chats? I don't know. Yeah. Regardless, thank you so much. How do you feel about writing your own compiler versus trying to contribute to OSS? My plan is to do both eventually. Like I'm building this just because like Loki is just fun. And I feel like I'm learning a lot more through just like fighting through the raw theory myself, but there's also a lot of like applied value to be attained through contributing to open source stuff. So I think a balance of both is probably good. Maybe in the future I'll like set aside 1 or 2 days a week to work on open source stuff. Maybe that's like my weekend. I don't know. Yeah, we'll see what happens, but I imagine that would be like something that you could also try as well. Let's see how my fantasy team is doing real quick. Lad McConkey has scored 0. That's not ideal. That's very bad, actually. Okay, adjacency lists. What's your motivation to go into compilers only? I just think compilers are really cool. I think they cover a bunch of different areas of theory that are that like I guess usually you would think of as like independent, but they kind of come together to like just make something really cool. Like obviously it takes programming languages stuff and like computer architecture stuff, just for like obvious end-to-end reasons. But there's also a lot of software engineering that goes into compilers and a lot of like algorithms in theory as well, which I think those 4 things are like the 4 things that I find cool about computer science. So it naturally makes sense for me to, I guess, pursue the one area that combines them the best. How do you set aside time for projects while focusing on school? I guess like stream time is kind of my project time. I try to set aside 1 or 2 hours a day. And it does have to come from somewhere, and usually for me that's just like time with friends, unfortunately. But I try to budget it in some meaningful way. But like if school is like really getting intense, like yesterday I had to like study for a final that was today. So I canceled yesterday's stream, for instance. So obviously like you shouldn't like fail school, but like it's very I guess it's pretty feasible at least to set aside time every day. To some degree at least. Okay, this all seems reasonable enough. I'll look at coalescing next time if the coin flip agrees with me. Okay. Heads, I end stream. Tails, I keep going. Okay, guess I'm still going. Okay, great, wonderful. It really wants me to keep streaming, I guess. God damn it! I think I'm gonna go insane. OSS feels like things are mostly quite mature. I think it's like, for what it's worth, I think it is useful in terms of just like getting familiar with like working with already existing code bases. Like even just like in future projects, like a lot of like your future work, you will just be like plopped into the middle of a code base, and like you'll need to figure out what's happening. And then finally start making meaningful contributions. I think working with open source stuff gets you really familiar with that. And if it's like domain specific, that's like even better as well. Lives are great, but what you can also do is if you have some time, create a video. Yeah, we'll see what happens. Video production, at least up to the quality I would want, is like I'd want to like edit it down a little at least. So that might be a little bit difficult time-wise, but I don't know. We'll see what happens. I have some ideas on the back burner at least. When did you start programming? I technically wrote my first couple of lines of code in like 4th grade, but I think I only started writing meaningful code around like, I don't know, like the summer after freshman year of college. So I'd say practically speaking, I've written like proper code for like 2 or 3 years probably. Okay, so what's happening here? Register coalescing. Copy propagation, that eliminates copies. Searches the intermediate code for register copy instructions. Such that they do not interfere with each other. If that happens, then we can coalesce them. Modify and put the results into the other one instead and removes the copy. That makes sense. Okay, and then we just combine the nodes, which, sure, fair enough. Yeah, okay, so this was just like a do until no changes. Yeah, this pseudocode I'm not gonna look too closely at yet. Oh wait, that's quite nice actually. That is very nice. Can migrate parameters, pass in registers. Routine instructions required source. Da, 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 da. Interesting. Okay. Spill costs. Okay, yeah. Yeah, so we won't be able to fit every register sometimes. So sometimes we'll need to spill. That will make a mess. And we want to spill the cheapest register. I don't understand what's happening here. One company is aggressively hiring compiler engineers that has tensor. Oh boy, dude. You're gonna find this really funny. One of my friends works at TensorRent. Asked them to refer me. I did not get lucky this past application cycle, but hopefully things will go better once I'm recruiting for full time. What does the timeline look like for me who's done with CNOS principles? That's a very good spot to be in, honestly. I think web dev is still very much an option. You just need to you kind of just need to typecast your projects a little bit more. So you probably want to work on, I guess, more React related stuff. Probably this goes to the point of just making something with impact now, I guess. Whether it's something that you will use, or something that other people will use, or something that people online will use. If you can build something with impact, I think that will help them most, resume wise at least. Skills wise, I think building anything with a modern tech stack will probably get you the skills that you need. Yeah, you should be in a pretty good spot, I think. Ah, this is annoying. This is gonna make a mess. Yeah, I'm gonna look over spill costs again next time. Yeah, okay. I would flip the coin again to check if I'm allowed to stop stream now, but low key my voice is really quitting on me, so I should probably call it here. Yeah, I didn't end up writing any code, but that's kind of to be expected. I think next time I will try to start liveness analysis. We'll see what happens. Yeah. Thank you all so much for showing up to today's stream. If you're new here, make sure you sub to the channel and like the stream. It really helps out a lot with the algorithm and gets my content out to more of you. Also, while you're in the description, make sure you join the Discord. The link is down there, and it's the best place to get pinged when I go live, and yeah, best place to get pinged when I go live and just chat with everyone else. Is web dev still relevant now? I think it's still pretty relevant. You'll just have to get really comfortable with using generative AI tools. We're trying to land a job in compiling. I like compilers. There's not much else of a reason to that. Yeah. Like, stream, sub, Discord. Oh, GitHub and LinkedIn are in the description as well. Add me on those to stay up to date with what I'm doing. Yeah, I'm gonna go rest my voice now. I'm super dying. Take care, y'all. Take it easy. Have a wonderful rest of your day wherever you are.